guys, good morning. We're going to begin talking about basically ignition system. The ignition system is that system that creates the spark at the spark plug to ignite the air and fuel mixture that's compressed into a very hot explosive charge by the compression of the piston. So what an ignition system does is takes the spark plug, I'm going to try and get this thing, yeah, it's focusing on it, and causes a spark to jump between this side and that little round center terminal right there in between. And I'm going to illustrate this to you this morning very graphically. I'm going to show you that. It uses this device called an ignition coil. It's a step-up transformer. Transformers on the poles out in the community are step-down transformers. They take the voltage from about 4,000 volts down to 110 for your house. Okay. You say, well, hey, how about 220? Well, you get 220 by bringing 210 volt wires to your house and joining them with a breaker on the panel. We call those 210 volt legs is what we call them. Anyways, this is two coils into one. This type of ignition system uses it's called a DIS or waste spark system. It has one coil here and one coil here. Each one fires two cylinders. That's like the car that we have here, this '09 Forester. So what I'm going to do is I'm going to pull a spark plug wire and show you the spark. Before I do that, I want to take the camera and come over to the car. And when you look at the car, you'll notice these two blue cables here and these two blue cables here. Super engine's a horizontally opposed or pancake engine. It's got two cylinders going towards the driver's side and two cylinders going towards the passenger side. The pistons are laying horizontal in both directions. So what these four wires are, these are the spark plug wires. And that guy right there, you can see it, is the ignition coil. It's a little hard to see. It's bolted sideways to the top of the intake manifold. And these wires carry high voltage electricity, high voltage, low current electricity to the cylinders to ignite the air and fuel. So what I want to do is I'm going to reach down here and unplug one of these wires, which I just did. And I'm going to go like this. Sorry, I guess I can't see there. I just unplugged that wire from number 2 cylinder. I'm going to take my spark plug. I'm going to set the camera down right here so you can see what I'm doing. I'm going to take this spark plug and just push it in and snap it on just like it is. And then I'm going to take the ground wire. And the ground wire, this jumper wire with these two alligator clips, I'm going to connect one to the negative side of the battery. And this wire has a very thin insulation, so I don't want to touch this while I'm doing this, otherwise I'll get shocked. Okay, so this is the one place on a car where you can't get shocked is the ignition system. And the ignition system is a high voltage, low current system. I'm going to go ahead and put the camera right here so that hopefully you'll be able to clearly see that spark. So I'm going to put my hand in front of it so it should focus on there. Okay, having a little trouble getting it to focus. Let's see if I can get it to focus here. Sorry, a little technical audiovisual difficulties. Okay, so if I put my hand behind it, you'll be able to see that spark really clear. So I'll start the car now, and I'll try and get my camera to stay put. It is not cooperating real well at the moment. So let me grab my, grab this guy up here, get him ready, and get this guy ready. And I'm going to go ahead and start the car. Okay, there we go. Hopefully, you can see
here. See if I can get it to focus. Come on, dude, focus. Come on, focus. So I'm struggling to get this thing to focus. And you can see the spark jumping between there. And I just can't get it to focus on that, which is a bummer. Let's see if I put it flatter here. You can see that bluish purple spark. And if I put my hand there it focused, finally. See that spark in there? Okay, pretty cool. Shut the car off.
I apologize that it was so hard to get that thing to focus on there. That spark, that little blue spark that you saw, was roughly 10,000 volts, 8 to 10,000, 8 to 12,000 volts. And of course, the engine was misfiring because it was because it didn't have that spark plug wire on its cylinder. So, anyways, let's continue on in the classroom. So what we're going to be doing here is talking about the ignition system, its parts and functions, and how it creates that little spark that ignites the air and fuel inside that compressed air-fuel mixture composition in the cylinder. So here we go. So the ignition system's functions go like this. First, its first function is to turn the engine on and off. On a gas engine, we turn the engine off we used to just turn only the spark off. Now we turn the spark off, we depower the computers, turn the fuel pump off all at the same time. But primarily it was to turn on and off the engine by turning off the ignition system. It's also, second function is to produce a high voltage spark at the spark plug to ignite the A/F mixture. And the A/F mixture is my abbreviation for air-fuel mixture. And at sea level, the ideal air-fuel mixture, and we use a chemistry technical term to describe the ideal air-fuel mixture or the ideal chemical composition, is the stoichiometric air-fuel ratio. That's the chemically correct or ideal air-fuel ratio. At sea level, 14.7 parts of air to 1 part of fuel by weight, not by volume, but by weight. So a tremendous amount of air is used to burn 1 part of gasoline. If we say 1 gallon of gasoline, a lot of fuel a lot of air is used to burn 1 gallon of fuel. Okay, so we got to produce a high voltage spark to ignite that air-fuel mixture. Third, we want to distribute the spark to the correct cylinder, and we're going to say at the correct time, and I think that's the next bullet point. But we want the spark to go to the right cylinder, because in the 4-stroke cycle, if my hand is a piston, I go down on intake, I go up on compression, I go down on power, and I go up on exhaust. Where is it that I want that spark to occur? I don't want it to occur on intake or on compression, but I want it to occur at the end of the compression stroke, and the beginning of the power stroke is where I want that spark to occur, and I want it to occur in the correct cylinder. Okay, so in other words, in the cylinder that's at the end of its compression stroke, that's the one that needs to get the spark. And then I say here timing, so it controls when the spark occurs. So does it occur, in this cylinder when it's on compression right at the end of the compression stroke, or right at the end of the compression stroke, or in reality, we started a little bit before the piston's all the way at the top. We say before top dead center, usually 6 to 12 degrees before top dead center at idle, somewhere in there. And then at freeway speeds, when we're going maybe 3,000 revolutions per minute at roughly 75 miles an hour, the spark may be occurring at, say, 50 degrees before top dead center, because because everything's happening so fast, we need to make the spark occur earlier so it has time to ignite the air and fuel. So when the piston is ready to go down on power, the explosion's ready to push the piston down on power. So what you've got in this picture is a picture of an ignition system. There's a piston connected to the crankshaft. There's a valve there. There's a spark plug showing a little explosion. Here is a coil pack, we call it, similar to the one I just showed you. This is one type of ignition system. There are 4 or 5 different types of ignition systems, roughly. This one uses a computer and uses some sensors so the computer can decide when it's going to make that spark occur, basically, into that spark plug, and to ignite that air and fuel. So here we go. So next, the components of an ignition system go like this. The first is the battery. So the battery is involved in initially sending power into that ignition coil to make a spark. So just like the starting system, charging system, the battery is initiating everything. Once the car starts, the battery is not powering things up anymore, as you learned in the charging system, but it is the alternator in the charging system. So showing a picture, a little bit of a cutaway of a battery. Second component is the ignition system that's going to be used to turn on and off the system. So here's a set of keys, and there's a couple of lock cylinders, etc. This is an ignition lock cylinder. These are door lock cylinders. Most all keys today have a chip inside them that talks to a little transceiver that's around, a little device that's around the cylinder, right next to it, one or the other. And so it's saying, I don't want you to crank this car and start it unless I've got the right key. So that prevents, it's a theft deterrent and prevents cars from being stolen so easily. But the ignition switch is used to turn on and off the system. Whether it's a push button or whether it's a key type, it's still turning on and off the ignition system, amongst other things. Third is the ignition coil, and here's where you need to spend a little bit of time. So the ignition coil is a device that steps up the voltage, so it is a step-up transformer. Now, it's making voltage go from roughly 12 volts, 12.6 of fully charged resting battery. During cranking, the battery voltage drops to about anywhere from 10 to 11.5 volts because we are pushing current through the starter motor. Once it starts and the alternator starts running, this is going to be closer to 14 volts, a little bit maybe 14.2, 14.3, depending on the car. The ignition coil is going to boost that 14 volts roughly when we're running up to roughly 30,000 volts. Now at idle, most cars idle about 10,000 volts. But when they're going down the road, they can be at 20, 30, 40, 50,000 volts. I've seen Ford systems that'll make 100,000 volts. Very, very high voltage. It can't hurt you. It does shock you. It's like a very strong static shock, but it doesn't electrocute you. And I define, and it's my own definition, whether or not it's technically accurate is probably not, but I define electrocution as being where current's flowing through you and you can't let go and you're constantly being electrocuted, where this will just, typically just give you a zap and that's it. Can it hurt you? Can it kill you? No, not possible. It's way too low of current. It has high voltage, but it's just like a very strong static shock. And if you guys were here, as usually I usually take the whole class. We all hold hands. One person touches the spark, and the other person touches the battery ground or the engine block, and we all get shocked at the same time. It's really cool. You'll like it. Anyways, so let's talk about how a coil is constructed. It is a step-up transformer, so it's boosting voltage from very low to very high. The transformers on your poles are stepping the voltage down for your house. Okay, so we take roughly 4,000 volts going down the street for PG&E, and we bump it down to 110 volts. So ignition coils, and here's one style. This is a DIS coil. This is an old school can coil, and I've got one of those here. So here's the difference between these. Here's an old school can coil, and it looks an awful lot like the transformer up on a telephone pole. Here's a DIS coil, which is actually 2 coils in one. And then here's a modern car. This is a Honda coil on plug coil. This is an individual coil that snaps right onto one spark plug. So it goes just like this. You take this coil and we push it on the spark plug, and that's how it is in the engine. So this one has no spark plug wire, the long blue cables you saw out there on the Forester. It does have some 16 gauge wires plugging in here that turn this guy on and off, but this guy is boosting the voltage from roughly 14 volts to anywhere from, again, 10,000 to 30,000 volts. So what I want to show you is what's inside this coil. We'll look at a CAN coil because it's easier for us to take apart. These are constructed with 2 coils of wire inside with some segmented iron bars down the center, and it's inside a non-conductive oil. And it's kind of interesting, that's very close to what you have on the telephone pole. That non-conductive oil cools it, and these would very rarely fail back in the day. So when I was in high school, this is what everything was. I graduated in 1981, and pretty much every coil was like this, okay? In the mid-'80s, they started changing, and then they changed significantly when we went into the 90s. But it shows here a primary coil, primary windings, same things, primary coil, primary windings, and secondary windings or secondary coil. So inside you have 2 wrappings of wire. The primary windings are several hundred turns of heavy wire. Okay, so this is the primary, and this would be roughly 16, 18 gauge wire. The secondary is thousands of turns of very, very fine wire. So here's the wire. Here's a CAN coil with the primary wire, probably an 18 gauge wire. It is copper, it is solid, and it is coated with plastic so that these wires don't short between each other. And then here's the secondary, and the secondary is really hard to see. You can see the wrappings of copper there, but if I grab the end of it, and let me do that, one sec here. So it's going to be very hard for you to see. I'm going to put it in front of my hand to see if the camera will focus on the wire, and it's hanging right here. I've got it in my, okay, there it is. You can just barely see up. You can see it now, it's focusing on it. Little tiny fine hair-like wire. And it is like hair. It's roughly 1/1000th of an inch, 2/1000ths of an inch thick. And it's all wrapped around these layers of paper. And inside the ignition coil, here's the primary, here's the secondary. This just slides inside. The magnetism that's created goes right through this paper wrapping. The paper wrapping has no effect on it at all. Down the center of that coil are these segmented iron bars right here. So these would be, here's another one. This one's kind of pretty. There's another wrapping of secondary wire, and you can see the wire pretty clearly there. And these segmented iron bars go down the center to strengthen the magnetism that's made. Let's talk about, and that's the iron core that I'm talking about, those segmented iron bars. Let's talk about how this thing works, okay? Well, we'll get to it in just a moment, sorry. But that's an ignition coil, I should have said. So the ignition coil has a primary winding or coil, a secondary winding or coil, these segmented iron bars, and it's a step-up transformer. So next is spark plugs. So the spark plugs are going to ignite the air-fuel mixture. Okay, and here's a another one there. So a spark plug is going to ignite the air-fuel mixture. It just gives us a little center terminal and side terminal between which a spark can jump and ignite the air and fuel that's all compressed around it. Okay. So high voltage ignites air and fuel, A/F, mixture, air-fuel mixture in the cylinder. The center and side electrodes, center there, side here, are a connection, like it says, for the spark to jump. So the spark plug has a connection for the plug wire here to snap on. It conducts spark to the cylinders. It goes down through, and then it jumps between the gap there. Some spark plugs jump from the center terminal to the side. Some jump from the side to the center, but that's another class. But these thread into the cylinder head with this hex here. We can get it off with a wrench. Got a porcelain insulator, and high voltage electricity goes down through the center of this and jumps to ground. Okay, that's the spark plug. So next, on some cars, we have what's called a distributor. Old school cars up until mid 90s, and if it's a Honda, all the way until 2000 roughly. And so we had what was called a distributor, and a distributor was a fairly large rotating mechanical device. I'm grabbing one right now, like this. You can kind of get an idea of the size. This is from an old Chevy 350. Would have been out of like my old Nova or something like that. Gear driven off the camshaft, spins that guy in there. And this guy's whole job was to distribute the spark to the correct cylinder at the correct time. Modern cars don't use a distributor anymore, but they use some sort of an ignition module. An ignition module is a solid state, no moving part device that's used in conjunction with ignition coils or coil on plugs to fire the plugs at the correct time. Some people who know a lot about ignition systems would say, really, you want to compare a distributor to a module? Well, early electronic ignition, computer controlled distributors had modules inside them, so they were kind of incorporated to it. But anyways, they are involved, both are involved in turning on and off that ignition coil to make the spark. That's how basic we're going to keep it at this point. So they're going to switch the distributor or the module. We're both used to switch the coil on and off, or off and on, either way you want to look at it. And then send the spark to the correct cylinder at the correct time. And that's obviously very important because we want the thing to run right, and that's got to occur at the end of the compression stroke, right before the power stroke. So whichever cylinder is on the end of its compression stroke, it needs to get a spark. Okay, so that's that. So next is we have wires in the ignition system. So first we have what's called primary ignition system wires. These are low voltage wires that are from anywhere from 9 volt to 200 volt. They are 16 gauge wires. Really, it should be more like 10 volts, but 10 volts to 200 volts because during cranking, there's only about 10 volts going through them. And then once the engine's running, there may be as much as 200 volts depending, but that's a little bit confusing, I suppose, to you, and so we'll kind of leave that and just say it's roughly 14 volts. In any case, the secondary voltage is 10 kV, that's 10,000 volts to 50 kV, 1,000 volts. These are very, very thick insulated wires. We call those spark plug wires. And I'm grabbing one down here to show you like we saw earlier. And here's a spark plug wire here, and it's got a very, very thick coating. I've cut this guy open, and it's got this graphite sort of impregnated, looks like fiberglass core, and the electricity will conduct down that. And then it's got this very, very thick insulation. Let's see if it'll focus. Yeah, it's kind of focusing. There we go. And we got this very, very thick insulation to keep the spark from jumping from the center of that wire to ground on some metal part. So we're going to, the secondary is going to conduct high secondary voltage to the spark plug. Let's go back to the primary for a moment. So basically the battery, the alternator is bringing low voltage in. Those are 16 gauge wires. The secondary side is going to conduct high secondary voltage to the spark plugs. Spark plug wires are what we call resistor wire. They have thick insulation. They're resistor wire, so believe it or not, we don't get a lot of magnetic field interruption of your radio reception. They have a synthetic fiber core with carbon, preventing, I said graphite, it's carbon, preventing radio interference, like I just said. So not graphite, carbon. Okay, here we go. So here's how an ignition coil operates. Okay, so ignition coil operates, and I'm not sure exactly why that's not focusing. Let's see if I can get it to focus on me. Yep, focus on me. There it goes. So the ignition coil operates by putting current through a coil, producing a magnetic field. So anytime I take electricity and put it through, this secondary is stuck on here. Anytime I take electricity from the battery or from an alternator, and I put it through this coil wire, this insulated 16 gauge solid copper wire, I make a magnetic field, okay? And if I put current through a wire, I make magnetism. If I wrap it into a coil, I make much stronger magnetism. It becomes an electromagnet. If I put segmented iron bars down the center, I strengthen the magnetism. And so what we do is we put current and make a very strong electromagnetic field, okay? If I turn the current flow off through this coil, if I just shut it off, we say that the field or the magnetic field collapses. Now, you say, what do you mean by collapses? Well, when I don't just use the word turns off or shuts off or ceases to exist, because that's not what happens. As the current flow shuts off, the magnetism will sort of dissipate out and it will affect things around it. So we say that it induces, that is to put into something else, it induces or puts in a high voltage surge in the or causes a high voltage surge in the secondary windings. Let me explain. That's my fancy English. So if I've got current flowing through this coil and it makes a very strong magnetic field and it's surrounding all of both the primary and the secondary, which is down the center here, and I shut this current flow off, the magnetic field collapses and causes a very, very high voltage surge in this secondary. You say, well, why does it step the voltage up? Why does it go to high voltage? It has to do with the number of turns of wire. If this had less turns than this, I would step the voltage down. Because this has way more turns of wire than this, the voltage bumps up quite high, okay? And so it's a really, really simple magnetic principle that happens in nature that I can use to boost voltage to get enough voltage to jump a gap on a spark plug. The voltage of the battery and the voltage of the alternator are nowhere near high enough to jump a spark plug gap, which usually is around 40 to 60 thousandths of an inch. Okay, so again, if I look at this spark plug here and I put my hand behind it, so hopefully it'll focus for you, the gap on that, oh, there it is, that gap on that spark plug right there is about 40 or 45 thousandths between that side electrode and that center electrode. Okay, roughly 40 to 45 thousandths, somewhere in there. Some go as high as large as 60 thousandths, but we need a high voltage surge to get across that. So the ignition coil, being a very, very simple device with those two wrappings of wire, can boost the voltage and create a spark and cause there to be a spark to ignite the air and fuel. And that may be all we have. Let me see if, yep, that's it. All right, so that's a little basic introduction to the ignition system. And we'll be showing you some things about changing spark plugs and gapping spark plugs and a few other things like that in some ensuing hands-on demonstrations. This for now. All right.